Friends, welcome to my YouTube channel. Dhanesh here. In the last video, we were discussing about t-test. In this video, I am going to have a comparison between z-test and t-test. Let's start. This is a quote from Sir Isaac Newton. If I have seen further than others, it's by standing upon the shoulders of giants. Let's continue. See, first I'm giving some idea about C-test. Before that, I am getting into a nice table. This is as part of this is part of exploratory data analysis (EDA). That is bivariate analysis is there. Bivariate analysis means there are two variables will comes into picture. That variables can be numerical and categorical. If both the variables are numerical, we will go for correlation coefficient. If both are categorical, chi-square test. If one is numerical and another one is categorical, we will go for t-test, c-test, and ANOVA. Fine. So we have videos for these aspects. So you can here we are comparing the difference between t-test and c-test. This is a very nice table for you to understand. First, I am telling what is z-test. A z-test is a statistical test to determine whether two population means are different when the variances are known and the sample size is large. Here, two conditions. The sample size is large, you will go for z-test, and the variances must be known. Then only you can go for c-test. It can be used to test hypothesis in which the c-test follows normal distribution. This is another important aspect. When there is normal distribution or Gaussian distribution or bell curve, you will go for c-test. A statistic or z-score is a number representing the result from the c-test. We will give the math for that as well. See, characteristics of z-test. It can be used to test hypothesis in which the z-test follows a normal distribution. Then only you can go for z-test. A z-statistic or z-score is a number representing the result from the z-test. A z-test is a statistical test to determine whether two population means are different when the variances are known and the sample size is large. We already discussed these aspects. These are all the characteristics of z-test. Fine. This is the equation for z-test. This is a really good equation, nice equation. You can learn it. X bar is the sample mean. Mu zero is the population mean. You are familiar with the difference between population and sample. We have the videos in the playlist. You can watch it. But this is a simple concept. So X bar is the sample mean and mu zero is the population mean. N is the number of samples. So you need to understand it. And sigma is the standard deviation. There is video available. Standard deviation gives the spread of the data. So you understood. This is the math of z-test. This is the nice equation for z-test. You got it. See, this p-value versus significance level in hypothesis testing. This p-value and significance level is represented by alpha. These two parameters are very important in a hypothesis testing to tell whether we need to reject the null hypothesis or we need to accept the null hypothesis, or we have to accept the alternate hypothesis. Everything depends on p-value and the significance level alpha. It is a Greek letter we use to denote significance level. These two are very important. You have to learn it. There is separate video in the playlist. Please watch those videos and learn it. If the p-value is greater than alpha, you assume that the null hypothesis is true. Very important. If p-value is greater than alpha, we have to assume that the null hypothesis is true. If p is greater than alpha, the null hypothesis is true. If the p-value is less than alpha, you will assume that the null hypothesis is false. What do you do? So if both are very close, you will collect more data. That's what you do. See, this is the critical area. The shaded portion is the critical area from where we start. Here this point will be the alpha value will be 0.05, that is 5%. significance level. See, how do you find out this point? This critical point can be found out by z-score or IQR score, intra-quartile range. That's also there. Even we have the box testing or whisker testing. Everything is available. So all these aspects are part of feature engineering, and we detect, how do we detect outliers. See, that, and we have the videos there for that as well. Fine. See, this is a important concept for p-value and significance level. Now I am getting into the t-test. T-test is a type of statistic used to determine if there is a significant difference between the means of two groups. That is the importance of t-test. The t-test was developed by William Sealy Gosset 100 years ago to determine the difference between Barley from different fields. T-test, we also call it as student's t-test. Fine. The t-score. The t-score is a ratio between the difference between two groups and the difference within the group. A large t-score, difference between two groups means between the mean. So this is the first normal distribution. This is the second group. So the mean of the first group is this. The mean of the second group is this. The difference is this. Is the difference between the two groups, and the difference within the group we will find out by the variance. I will give you the math for that. A large t-score tells you that the groups are different. A small t-score tells you that the groups are similar. Fine. This is the math of t-test. T-score is this is a signal by noise. Signal means difference between the two groups, difference between the mean. Noise means the variability. I told you, here also the difference within the group, that is given by the variance. So the difference between group means, that is x1 bar minus x2 bar, that is the this is x1 bar. This is the mean of the first one. This is the mean of the first group. This is the x2 bar will be the mean of the second group. So x1 bar minus x2 bar, the whole divided by root of s1 square by n1 plus s2 square by n2. What is s? S is the variance. So S1 means variance of the first group. S2 is the variance of the second group. What is N1? N1 is the number. N1 is the number of samples in the first group. N2 is the number of samples in the second group. This is simple. Really, really interesting. That is the math of the t-test. This is the mathematical equation behind t-test. If you have independent groups, because there is no correlation between the samples, then you can go for this equation, sigma 1 square by n on t score, to find out the t score, sigma 2 square by n2. Sigma 1 is the standard deviation of the first group, and sigma 2 is the standard deviation of the second group, and n1 is the number of samples in the first group, and n2 is the number of samples in the second group. Fine, easy. T-test for dependent groups, there is a correlation between the samples. Then you can go for this equations, root of sigma 1 square plus sigma 2 square minus 2r, sigma 1 sigma 2, where r is the correlation, because this is a dependent groups, so there is a correlation, and sigma 1 and sigma 2 are the standard deviation of the first group and second group respectively. So this is the difference between z-test and t-test. Z-test works for sample size greater than 30. T-tests are best performed when an experiment has a small sample size. So z-test is for larger sample size and t-test is for small sample size. Z-test assumes standard deviation is known. T-test assumes that the standard deviation is unknown. This is the difference. This is the different test, and the degree of freedom is given. For one sample t-test it is n-1, two sample t-test it is n-2. For chi-square test it's given. This table is a nice one. If you want, you can learn this. For chi-square test, we already have separate videos for chi-square test, t-test, correlation, everything. You can watch those videos. This degree of freedom is a very important factor, as I discussed, significance level and p-value, probability value. Fine. So that's all. Thanks for watching. Please like, share and subscribe. Thanks a lot.